Hi everyone, welcome to Econossense Beginner Python course. This is a short course that will teach you how to program using Python. Let's first begin by defining exactly what we mean by programming. Programming is just giving a computer a list of commands to execute. It's just like a recipe to do something. A recipe for scrambled eggs will look something like this. Break the eggs and put the contents on the pan, cook it while scrambling it, then put it on a plate. In a similar way, say we want to make a robot or a website. We need to follow a bunch of steps in a given order to make it do what it does. In the case of a robot, it could be to move objects from one place to another. For a website, it's going to be displaying some information in the form of web pages when a browser sends a request to a particular URL. In order to express these steps or recipes to the computer in a way that it can understand, we need to use programming languages. Python is one of the many languages that you can use to talk to computers. Python happens to be a very powerful programming language, so you can do a lot of really cool and awesome things with it. By the end of this video, you're going to create your own to-do list app. Let's head in and start writing some awesome Python programs. Okay, to begin, we're going to use this website that Google has made. I'm going to type out the URL right here. It's colab.research.google.com. We're going to write our code inside notebooks inside of Colab. So it looks something like this. So let me go ahead and just say new notebook. That's what you should be doing too. And then it's going to open up this in a new tab or a new window, depending on your browser. The cool thing about Colab is that you can write all your code over here, and then all you have to do is save it like this, and then you can access this notebook that you created from any device. You can even use your smartphone, and it's really no different from how you would do it on a laptop or PC. So let's say you don't have a laptop or a PC for some reason, so you can just use this website on your phone. So all you need to do is go to your internet browser. I recommend Chrome, and just pull up this URL that I gave you, right? That's colab.research.google.com. Then create a new notebook, and this is what it's going to look like. First, let's go ahead and name our file so that we know which file we want to pull up if we ever come back to this. I'm going to go ahead and call this PyLesson1. And feel free to give it whatever name you choose, but I like to keep my name simple, so I'm just going to give it PyLesson1. And we're going to write our code here in this area. So these are called cells right here. So I can type in anything I want here. So most of it is going to be code, but there's also an option to kind of write some text in here. But don't worry about that for now. You can write your code here, and you can add new cells as you go using this button. The plus code button is going to give you more cells, and you can use the delete button right here to remove any unnecessary cells. Okay, so now that we know where we're going to write our code, let's just get into this. Our first program will be to make the computer display the words "Hello World." It's just the program being really excited to talk to the outside world. In Python, there's a function called print that does this for us. So I'm going to type in print, all in lowercase, and then I'm going to start some brackets. And these brackets are really important. We call these parentheses. So you'll hear me refer to parentheses again and again. And I just want you to remember that it's just these brackets right here. So these are called parentheses. Whatever I put inside the parentheses, I'm telling the program that I want to send that thing into the print function. So let's say, I type in a few numbers. What I'm telling is that by putting these numbers inside the parentheses, I'm telling the function that I want to send these things inside the print function. So right now we want the computer to type the words "Hello World." So I'm going to put that there. And let's run this program. The way you run this is by clicking on this button right here, which says Run Cell. It looks like the play button on your music player or whatever. So here we're going to press the Run button. Let's see. This might take a while. So Colab will first connect and initialize your system, and then it runs the thing. Looks like we got a syntax error. So a error is basically when the computer doesn't understand quite what you're saying. So you need to correct the way that you're saying it so that the computer can understand what you're saying. So this is a very common error. So I want you guys to pay a lot of attention right now. It's a very common mistake for people when they're beginning to code to put in things without quotes, and this will give rise to the syntax error. So in order to fix this, as I said before, we need to put in some quotes. So I'm going to put in some double quotes, and let's see what happens when I click on the run button. Okay, great. So we got the output. It says hello world, just as we wanted it to. So remember, you have to put the quotes whenever you put in words, any kind of alphanumeric input, we have to put quotes around them. And it doesn't really matter what kind of quotes. I can put in single quotes instead of the double quotes, and let's see what happens. Yeah, as we expect, we get back our intended output. I prefer double quotes. It's just a matter of preference, but a lot of people do this too. So I'm just gonna revert these back to double quotes, and I'm pretty much going to use double quotes for the rest of this tutorial. So once again, let's run it, and as you can see, we have the words "Hello World" printed out. So this is your first ever program in Python, and you now know how to use the print command in Python to make it write whatever you want. Great. Let's just quickly change this to say hello, say Econoscent, just cause, and let's see what happens. Great, so it worked. So what we've learned now is that as long as you have the parentheses, the brackets over here, and then the quotes in the order that I've shown, you can put in pretty much anything in here, and the computer will print it out. Now let's get a little technical and give these things some names. Anything that goes within the quotes is called a string. Basically, the computer just sees anything that's in between the quotes as a sequence of characters. It doesn't see the meaning of hello or Econoscent or the space even. It doesn't know any of those things. It doesn't understand that this is a word and that it represents something. All it sees is capital H, E, L, L, O space, and so on. So it just remembers this as some sequence of characters. So great. So we know that now we can print out strings using the print function. Let's see if it can print some other things as well. Let's begin by trying to just print some numbers. Let's just say print 10. Awesome, that worked. Print 1. Great, that worked too. Notice that I didn't use any quotes in this example because numbers are not strings. They're not a sequence of characters. They're just numbers, and computers can understand numbers. Okay, so now let's make this program a little bit more complicated by adding another print statement. I'm going to just make it print the number 2. As you can see, the print statement here on the first line executed first, and then the print statement on line number 2 executed next. And order matters a lot in programming. So if I go ahead and cut this line and then put it above the first print, then the result also changes. So because I put print 2 on the first line, that gets executed first, and then print 1 gets executed next. Okay, now let's move on to learning something a bit more interesting. What's cool is that you can do any kind of arithmetic operations on numbers in Python. So for example, we can just go ahead, remove that second print, and then change this to print 2 plus 1. So let's see what happens. We see that it printed out number 3 rather than printing out 2 plus 1. And that's because any arithmetic operation first gets computed here, and then the output of that arithmetic operation goes inside the print statement, which, as you can see, outputted the result of 2 plus 1, which is 3. Okay, so now what if we put quotes around the arithmetic expression? just like this. What do we expect the output to be? Remember, when we put quotes around something, that becomes a string. It becomes not an expression, but a sequence of characters. Okay, let's look at the result. We have the result. It just says 2 plus 1. It doesn't give you the answer. And that's because we've changed an arithmetic operation into a string. And as I said before, the computer only understands this as a letter, some letter. It doesn't know that this is the number 2. And this also as another letter or character. It doesn't see it as the plus operation. And then again, here, the 1 is not the number 1, but just the symbol that indicates 1. And so it just prints them as is, very literally. Okay, let's quickly change this back to the operation that we had before, the expression. So we know that we can print out addition expressions. What about subtraction? Let's check it out. Awesome. That worked perfectly as expected. And we also have the multiplication operation. So let's just, for example, say 2 times 5. Note how the symbol for multiplication is not X or cross as you would have expected, but instead it's the asterisk symbol. And you're going to find that close to your numpad if you are using a PC. There you go. The answer is 10. That's perfect. And lastly, I'm going to tell you that the symbol for division is the slash symbol. It's this symbol. This symbol will help you do division in Python, but I'm not going to give you an example, but instead I'm going to ask you to tell me what the command would be to print out the result of 10 divided by 2. So I'm going to ask you to pause the video and try doing 10 divided by 2 on your own. It should be very simple. Okay, welcome back. We hope that you took the time to try the challenge by yourself and that you got the answer for 10 divided by 2 using Python. If you didn't, don't worry. It's rather simple and it looks something like this. Print, and then you're going to put in the first number. Remember not to put any quotes, because when you put quotes in, that means it's a string and we don't want that. We just want an arithmetic operation. And then you're going to use the slash symbol to denote division, and then number 2. Let's see what we get. Okay, there we go. Yes, 5 is the answer. Okay, great. Now we've learned how to do arithmetic operations on numbers. How about we learn some operations on strings? The most common string operation is called string concatenation. And this sounds like a very complicated thing, but it's actually very simple. It just means taking 2 strings and then joining them together. Okay? So let's write down a string here. Hello. And then another string that goes world. As you can see, it printed them out separately. But what if I want to, make them just one string? I could have done something like this, right? I can do this. And that's, perfectly reasonable. But this is just one string at this point. But we want to take 2 different strings, something like this, 2 different strings, and then somehow add them to make them one word. It's actually very intuitive. You would just use the plus symbol to add the 2 strings together. So string concatenation is just indicated by the plus symbol in Python. Okay. So as you can see, it printed out hello world without a space in here. And there are 2 ways to correct that. So one of them could just be, you can just add the space here. That looks fine. Or you can add the space here. That also looks fine. And then there's actually another way too. and that would be to have one other string just be the space symbol and then add that to the other two strings. You just sandwich a space in the middle of the two strings, and that worked too. So now we know string concatenation. Okay, let's move on to a new concept. Let me add a print statement above hello world that says hi. And let me run this. It says hi and then it says hello world. Let me now introduce the pound or hashtag symbol next to hi. Let's run that. Oh, we don't see hi anymore. What happened? What happened was that the pound symbol at the beginning of a line indicates to the computer that you want to ignore this line. It's saying, hey, if there's a pound symbol here, just don't look at the rest of the line. Just don't care about it. Just go to the next line. So the Python comes here, looks at this, says, I don't care about this line, and then goes to this line and then executes the command here. This strategy of using the pound symbol to ignore a line is called commenting. And this line that starts with the pound symbol is called a comment. And you might wonder why I would want to do this. The reason I'd want to do something like this is so that I can write plain English here. I can just say something like, this following line prints out hello world. And now Python doesn't care about what I've written. So it's not going to give me an error because, plain English is not valid code. But instead, it just highlights it in a different color and lets me know that this is a comment. So this way, when someone else comes along and tries to read the file that I've written, they can just read the comment and understand what my code is doing. Commenting is very important because it allows us to make notes about the code in the code file itself. Okay, great. Let's move on to the next concept. One of the things that computers are really good at is storing information. You can give an entire movie to a computer and it will save it as it is. It won't forget any parts. It won't somehow reshape some of it, and it saves it without any loss. So it's kind of important for us programmers to take advantage of this. The way we store data in Python is by assigning it a name. So let me go ahead and create some data. Let's say I want to remember my birth year, 1994. Let me just type this out. I now need to tell my computer to save it under some name. Let me pick the word birth year to be that name. Now all I need to do in order to put the data 1994 inside the name birth year is the equals symbol. By doing this, I have taken the data on the right side of the equal sign and put it inside the name or variable, as we call it in programming, by just putting the equal sign. Let's see whether this worked by first running the code and then printing out what is inside the variable birth year. Okay, let's run this. Success! We just printed out whatever is inside birth year and it happened to be 1994, exactly as we wanted it to be. Keep in mind that your variable names cannot have a space in them. So for example, if I went ahead and tried to put a space between birth and year, then I would get a syntax error. And remember, we got this before. So every time Python doesn't understand what you're trying to do, or if you made some kind of mistake in writing your code, then you're going to get this error. So the way I can fix this is by just removing the space or even adding a underscore and then running this. So let's try that again. I want to copy the new name and then put it inside the print statement. Let's run that. Great, it works. Perfect. Congratulations. We've just successfully stored some data in a computer's memory programmatically, and then we even retrieved it and printed it out. This process of assigning some data to a variable, as we just learned, is called declaring a variable. It means that you're kind of telling the computer, hey, from now on, when I say birth year, I want 1994 to come out. So it's called declaring a variable. Now let me try to do something funny. Let me try to print a variable that we haven't declared yet. Say birth month. Let's see what happens when I run this. Oh, we get an error. And this time it's not a syntax error, but actually it's a name error. And what that means is that we haven't declared this variable yet. So Python is telling us, hey, you're asking me for the data inside the birth month variable, but you never told me what it's supposed to be. So I have no clue. So let's go ahead and fix this. And an easy way to fix this is just to go ahead and create a variable called birth month, and let's put in a month, and here we go. We have successfully declared the variable birth month. We set it to January, and we were able to retrieve that variable and then print it out as well. Great job, guys. This is really awesome. One last thing about variables. Variables are not permanent. As the name suggests, you can change the value of your variable. Let's set a variable called flower and then set it to tulip. The string tulip. Let's then print it out. Let's see what happens. Oh, great. Awesome. Now, what if we try to change the value from tulip to daffodil? Let's print that. Let's move the print over here. Run it. We see daffodil. We don't see tulip anymore. So what happened was we first set the value of flower to tulip, and then we said, hey, how about we forget about tulip, and instead the flower we want to remember is daffodil. And then we asked it to print it. So that's why we got daffodil. Okay, great job, guys. Now let's move to a completely different topic. Let's say we had an email that we wanted to send to 10 people, and we want to address each one of the recipients uniquely, but the rest of the email is the same for everyone. Usually we would have to open a word processor like Google Docs and then copy paste each person's name manually into the document and then send the email. This would take a long time. So how about we create a program that does this really easily and really fast? First, let's do this using the things that we already have learned about. So let's say the email is something very simple, something that looks like, hey, and then your name, and then it just says something like, oops, how are you? Let's say that's the name, and then let's say that's the email, and we just have to change the name part for each of our recipients. How would we do this using Python? So we would do something like print, hey, name, how are you? Print that out. We get hey, name, how are you? And then let's say we got to remove the name part and put in somebody else's name. The hey would be its own string, and then we would add the name. Let's say for our example, the name is going to be Sarah, and then that's going to be its own string, and then the rest of the email is also going to be its own string. So we are using the concept of string concatenation, that is just joining strings in order to build this email, right? So we have the string hey with the space at the end, mind you, Sarah, and then we're adding how are you to the end of all of that. Okay, that looks great. So now if I wanted to change the name, then all I have to do is say copy, paste this, and then change it to Dan and say print. Wow, this is not bad. So this is, pretty good. But it kind of gets boring, or it kind of gets annoying really fast when you have to copy this statement over and over and over again if you have a lot of recipients. So we're going to teach you this method that you can use to encapsulate parts of your code in a way that can be called again very easily. So let me just explain this using this example. We're going to use something called functions in order to do this for us. I'm going to define a function called, say, email, that takes in some parameter, and that's going to be a name here. And then it's going to print out pretty much the same stuff that we were printing out before. But now, instead of putting a particular name in, we're going to say name, just whatever the parameter is here. Okay, so that was a lot of stuff. So let me just break this down line by line. The def keyword in Python stands for definition. What it means is that this keyword tells Python, hey, whatever comes after me, that's the definition of a function. This part is the name of the function, so that we know we have a way to call this function when we need. This part that's inside the parentheses, remember the parentheses, these brackets? This part is called a parameter or an argument. There are quite a few different names for most things in programming, but I like to usually call them parameters or arguments. And what that means is that this function needs something called a name in order to run. And everything that comes after this first line is the actual meat of the function. Also note that everything that's inside the function after the definition has a little indent. An indent is just a bunch of spaces. This is a way that Python understands what's inside the function and what's not. So be very careful about this. You need to give a few spaces. You need to indent the body of your function so that Python knows that this is supposed to go inside the function. Also, before I forget, there's this little symbol at the end of the first line. This is called a colon. It's just the two dots. The colon just indicates that what comes after is the body of the function. So you got to remember this. Def, the keyword that says this is a definition of a function, then the function name, then the argument or arguments, you can have multiple of them that go inside the parentheses, and then a colon symbol, and then the body of the function is always indented so that the program, so that Python understands what's inside the function and what's not. Okay, great. So now that we've made the definition, how about we call this function and see what it does, right? So you need to give it an argument or a parameter, and name is that argument or parameter over here. So let's just give it a name like Sarah, I guess. And let's run this. Great, that works great, awesome. How about another name? Malik. Hey Malik, how are you? So you see how we were elegantly able to encapsulate the logic of adding these strings and then printing them in this function, and then we could just go ahead and call this function whenever we wanted it with different arguments, and then it would do whatever work we wanted it to do. Okay, now that we understand functions, let's move on to a new concept. This new concept is called lists. Python allows you to store more than just a single variable at a time. Suppose you want to store a list of friends for something like a social media website, then it's really hard to do something like this. This looks really ugly and also gets really unwieldy when the number of your friends increases. So in order to combat having to write 1,000 different variables, we have something called lists. So let me show you how I would use lists to change this example. Okay, so we've gone ahead and created a list. Let's look at what this list is composed of. First of all, you've got to notice that there are square brackets this time. So these square brackets indicate the beginning and end of the list. Then what else do we have? We have commas. These are new. As you can see, there are no commas in the beginning or at the end of the list, but between every two list elements, there always has to be a comma. Let's say we want to print out only the first friend in this friends list. How do we do that? The syntax or the way you write this is pretty simple. It's just going to be the list's name, just like in variables. And then we open the square brackets and then we put in the number of the element we want. Okay, great. It printed out something. It printed out Dan. But Dan is not the first element in this list. Dan is actually the second element. So why did it not print out Bob and why did it print Dan? The answer is kind of weird. The reason is that in computer science, we actually start counting at 0. So 0 is 1, and then 1 is 2, and so on. So why do we start counting items in a list at 0? I don't really know, but that's the way it is, and we better get used to it. So the right answer is this. Now, I have a little challenge for you that I want you to try for yourself. Can you, using this notation, using the list and then the square brackets and then putting the number denoting which element you want, can you use this notation to print out the last element in this list? Pause this video and go and try it out for yourself and then come back. Okay, did you guys try it out? Hopefully you got the right answer. It's not that hard. The answer is just the number 2. And as I said before, we start counting at 0. So this is the 0th element, this is the first element, and then this is the second element, or third, but it's called the. Okay, great. Now let's see how we can add stuff to an existing list. In Python, lists are an example of something called objects. Objects have variables within them. For example, internally, this list holds these elements in different variables. Objects also have some functions associated with them to do interesting things. Most of the time, these are to change the internal variables of the object itself. The functions that are inside objects are called methods. Let's take a look at an example. We know that this list is an object, and that means it has some methods associated with it. One of these methods is called append. This method will take what we give it and tack it on to the end of our list. Let's just give it a try. In order to access the method of an object, we use the dot symbol, like this. Then we type the name of the method, append. Then we need to open the parentheses because remember any function, and methods are all functions, require you to send arguments within these parentheses. This time, the argument or parameter that we give to this method is going to be the element that we want to add at the end of the list. So for example, kitty. Then let's print out the list. There we go. We see Kitty at the end of the list. So append is a method for all lists, and friends is an example of a list that takes in an argument and tacks it on to the end of the list. Now, what if we want to delete an element from our list? There's another method for that, and it's called remove. The argument to remove is going to be the element that you want to remove. Let's just remove Kitty. And then we'll print out the list. As you can see, we removed Kitty from the list using the remove method, and then when we printed out friends, we saw the list without Kitty in it. So great. Now you know the basics of lists. You also learned a little bit about objects. There's a lot more to objects, but we will cover that in a later video. Do subscribe to the channel so you get all our latest lessons. For now, let's move on to loops. One of the things that computers are great at doing is repeating a task really fast. For example, instead of printing out every element in the list manually, we can tell the computer to do that with just a few lines. So instead of printing it out like this, what we can do is use a loop. Wow, so when we run this, we get all the elements in the list printed out one by one without having to explicitly go through each and every element inside the list. So let's understand what exactly is happening here. What we are saying is that for every I in friends, print I. I is just a temporary variable. So it's saying, give me everything inside friends, and we'll call every one of them at a time I. So when it goes through it, first I is Bob. So Bob goes into print, you get Bob printed out. Then Dan comes out, and Dan again becomes I. And then I is printed out, Dan gets printed out. Then we go to Daphne, and Daphne becomes I, and then you print Daphne, and that's what you get out here. You can use any name that you want here. So I can, for example, I can say potato, and then change it to potato over here too. And you get the exact same result. All this thing is a variable, temporary variable name for the elements inside friends list. And then each thing that comes out can then be, can be printed out, or you can do any other operation on it. So for example, let's say I want to add something to the beginning of the name. Then what I would do is I would do some kind of string concatenation for the potato string right here. So I would just say something like hi with a space at the end, and then concatenate that to whatever potato is. Let's run this. Hi Bob, hi Dan, hi Daphne. So as you can see, loops are a very useful thing in programming. You guys should be really proud of yourself. You've learned a lot already, and we're not stopping anytime soon. Okay, now let's do something different. Until now, we've been storing data and then retrieving it. Now we're going to reason about our data. One of the things you can do is check if a number is greater or lesser than another number. For example, let's say we want to make a program that tells people whether they have enough money for a PlayStation 5 or not. Our best guess is that a PS5 will cost $500 at release. Our first step is to create a variable to store the cost of a PlayStation 5. Let's go ahead and do that. I'm going to create a variable called PS5 cost and set that equal to 500. Now let's create a variable called savings. This will store the amount of money that we've saved. Let's say I have $499. This is a sad situation, I know, but bear with me. Let's write a line of code to check whether we have enough money and to print the answer. So what we're doing here is we're printing out an expression and we're saying savings is greater than or equal to PS5 cost. Let's run this. It says false. That's right, because savings is only $499 while the PS5 costs $500. As you can see, this is a logical expression. Just like we had arithmetic expressions like 5 plus 1 or 4 divided by 2, this is a expression, but it's a logical one. And the logical operations are checking whether something is greater than, lesser than, or equal to something else. And Python will execute that expression, it will run the computation, and then it sends in the result. For example, here, the result is going to be false. It's going to send that into the print function, which then prints it out over here. Okay, great. Let's move to a happier situation now. How about we reassign savings to 500 and see what the answer is. It's true. So great. So now if you have savings of $500, that means you can buy a PlayStation 5. Let's say we want to do something more interesting. Now let's say we want the program to print something different depending on whether we have enough savings for a PlayStation 5 or if we don't have enough savings for a PlayStation 5. To do this, we use something called conditionals. And a conditional in Python is written using the keyword if. And we say if savings is lesser than 500 or is lesser than the PS5 cost, then we're going to type out, oops, sorry, I executed before I finished my program. Let's say print womp womp, better luck next time, at least there's still the great outdoors to explore. Okay, let's run it. Ooh, I made a mistake. We get a name error because I refer to a variable called PS cost and we haven't declared PS cost anywhere. Instead, the variable should be called PS5 cost as I've declared it over here. So let me fix that real quick. Okay, let's run that. It didn't print anything. So this is very similar to English, right? We're saying if savings is smaller than PS5 cost and then a colon, then you print this. Also note the indentation. This is very similar to the function syntax. Remember the colon and followed by indenting the body. So again, we said if savings is less than this, print this. And it happens to be the case that 500 is not less than 500. It's equal. So that's why this gets evaluated to false. And when an if encounters a false statement, it doesn't do what's inside it. It only does it if it's true. So in order to make this expression true, we have to make savings lesser than PS5 cost or increase the PS5 cost compared to the savings. So let's just decrease the savings here. So let's do, you only have $100, right? Let's run that. We got to run it whenever you're changing the variable. Then let's run the if statement. Great. Now it prints it out because this condition that we've set here, right? The condition that savings is less than PS5 cost is actually satisfied. Great. Now let's add one more conditional. This time we'll switch the sign. So we're going to say if it's greater than or equal to PS cost, then we're going to make it print a very different thing. Okay, so we typed in saying, congrats, you're a step away from being a proud owner of a PS5. Let's see if this works. As you can see, only this statement is being printed because savings is still below 500. It's not greater than or equal to PS5 cost. So, as you can see, we've written conditions such that only one of them can be true at a time. Let's go ahead and try to make this condition true and make this condition false. Reassigning the variables and now running this again. Great. So now we have the message that's printed out when this expression is evaluating to true. Awesome. Now, I just want to simplify this a little bit for us. As I said, only one of them can be true at a time. So, there's a way Python makes this simpler for us. If we know that this is false, then this has to be true, then there's a way to make that work. The else keyword basically looks at the above conditional and says, if this statement is false, then run this. It's just like in English. If we say, if X, then do this, otherwise do something else. So the else is similar to saying otherwise. So once again, if saving cost is lesser than PS5 cost, we're going to print this out. But if it's not the case, then we're going to print this. So let's just go back and change this to a number that's smaller. Run this. We get the womp womp message. And now, if we have enough savings, the program is going to evaluate this and know that this is false, and then immediately it's going to jump into the else condition and look at what's in there. Awesome. One last thing before we move on. Remember the syntax. Whenever you have an if and an else, make sure to end the expressions with a colon, or in this case, just end the else with a colon, and then make sure you have indentation after them. Let's see what happens when you remove the indentation here. We get an indentation error. So let's just put that back in. Awesome. It works now. Now we know how to store numbers as variables and even compare them. Finally, we can move on to making our to-do list app. The moment that you've been waiting for has come at last. Before we begin, first let's write a small spec for what our program has to do. A spec is basically a list of features that you want in your program. So the to-do list program also has a spec, and it's a very simple one. It actually has just 3 items that we really need. Let me type them out for you. The first thing that we want from a to-do list is a way to display that to-do list. So that's a simple one. The second thing that I want from a to-do list is a way to add items to that list. And the last thing that I want from my to-do list is a way to remove items from that list. The way we are going to go about this is we are going to create 3 different functions that will do these 3 different spec items. Okay, let's tackle the first one. Let's call that display. Actually, before we create that function, how about we create an empty list? So this is a list. Remember, we use square brackets to create a list, and then we're going to keep it empty. Then let's move on to writing a function that will display the to-do list. Here we go. It's going to print out the to-do list. The str function that I've used here is just converting the list into a string that can be printed out. Don't worry about it much. It's just helping display the list in a way that a web browser can understand. Observe that I have not given any arguments or any parameters to the display function. That's because each time display is called, I want it to do the exact same thing, which is display this list and not any other list. I want it to only display this list that I've declared over here. That's why it has no arguments. Also note the def keyword, the parentheses still have to be there even though there are no arguments. And then we have the colon and then indentation. Okay, great. Okay, next we're going to write a function to add items to the list. This time there's an argument because I wanted it to add different items that I give at different times to the list. Do you remember the method that we used to add new items to the list? Take a moment here to pause the video and then do it yourself and then come back and check on the answer. Hopefully you got the answer right. Here it is. We call the append method in order to add elements to the end of the to-do list. The parameter here is item. It's going to be the item that I send it in when I call the function. Lastly, we need a function to remove items. Hopefully you remember the method that we used to remove elements from a list. Go ahead and try it for yourself. Okay, awesome. So with this, our program is ready. Now let's interact with it. First we run it. Then let me go ahead and call the display function and see what it gives us. It gives us an empty list. That's right, because the to-do list is empty at that point. Let's add something to our to-do list. Cooking. I need to cook tonight. Okay, looks like it got added. Let's just make sure that it did using the display function. Awesome. We can now see our cooking item added to the list. Let's add one more element. And also ask it to display in the same cell. Awesome. Our to-do list looks great. How about now we take one off? Let's say I just finished cooking and I want to remove that from my list. I'm going to call the remove function that we just wrote. Okay, it ran. Let's check if it works. Amazing. The cooking item is no longer in the to-do list and it's only gardening now. That's awesome, guys. We just wrote a to-do list app with just a few lines. That's amazing. Now, I'm going to make it just a little bit more complicated, but by doing so, we can now exit the Colab and then move to a web page. So we'll actually make a web app out of this program that we've written. It's going to be, it might look a little confusing, but trust me, all the concepts that it's using, you've already learned it right in this video. So let's go ahead and dive into that. I'm going to clean up my space first. Move this cell up. So don't worry too much about these lines. All we are doing over here is invoking some code written by other people that we want to use. And this is very common in programming. If you wanted to write everything that you are going to use, then it would take forever and you would never get a single thing done. So in coding, what we do is we import a lot of code written by other people who have shared it with the world. So right now, I'm importing some libraries that contain code related to running things on a web page. So the one that you care about is called Flask. Flask is useful to create backend systems for web pages. If you don't understand what that means, that's completely fine. Don't worry about it. We will probably have future videos regarding that. So please subscribe so that you get alerts when we do release those videos. But for now, all you care about is, all you want to understand is that Flask is something that takes our app and it kind of creates an interface using web pages. That's all you got to understand in this. Okay, so it's going to be pretty much the same program here, but we're going to add a few more things. So this is just importing stuff. So this is just bringing in that code so that you can use it right over here. Okay, so let's run this first. It's probably going to take a few seconds, not too long, but definitely takes a bit. Oops, it ain't working. I have a typo here, so this has to be Flask and Grok. Okay, it installed all of those things. So what it did was it went to the internet, it picked up a bunch of code, and then it brought it back right here. Okay, now how do we change our code over here to, make it work with the rest of the things? So what we're going to do here is create an app. And that app will begin having nothing in it. So I'm just going to write this, and you don't have to really understand all of this. I call this function, it's called run with ngrok. And really, ngrok, or whatever it's called, is not used a whole lot. It's only useful because we are running this within the Colab platform, right? Remember that this is Google's Colab platform. And the Colab platform doesn't usually allow you to check out websites inside of it, and ngrok kind of helps us do that. So don't worry much about this, but focus on the logic that we're trying to work on. Okay, so all this is doing is we're creating an empty app, and then we are saying, hey, I'm in Colab, so could you help me run it within Colab? And that's what this line is doing. Now for the meat and potatoes. Because this is a web app, we have to tell the app what to send the user when they go to a particular address of our website. So usually we begin with the home page of a website, right? So let's create the home page. So what we're saying here is that the root of the web page or the home page is going to take its output from here. And now that we're not printing output to the Colab anymore, but instead we are going to send it to our app, we can't use the print statement anymore. Instead, what we have to use is a return statement. And this is what it looks like. So we're not printing this anymore. We're saying, hey, whatever this is, send it to this guy. Or send it to whoever calls this function. And it's actually this thing that's going to call the function. So if we go to the home page, the app is going to call this function. And then this function is going to return this, which happens to be the string version of whatever is in our to-do list. Let's try this out now. To make it work, we need to add app.run. So basically we created the app here and we gave it something for its home page here. And now we're calling it and asking it to run. The output is going to look something like this. Don't click on the first one, but click on the second one instead. So this is going to be the address of our website. Let's click on this. Goes to a new tab. And wow, there we have it, an empty list. Not much to look at, but hey, you made this. It's your own website now. Let's just check that things are working by making a small change. Let's just start our to-do list off with already 1 or 2 items in it. Okay. Each time you run this thing, it's going to give you a different one. So the old one won't work anymore. There we go. There's our to-do list. It's awesome. How do we go about using these functions that we defined? How do we add routes to our app such that these functions can be used? It's kind of simple. All you have to do is go ahead and do app route again. But this time, let's give it an endpoint that's different from the home, and then also allow a wildcard. The wildcard is basically anything. You can type in anything here, and that goes in as the argument to your add function. And then the function runs. All's good, but this function does not return anything. So the app has no output to show you once this runs, because it's only changing the to-do list, but it's not really returning anything to the app itself. So we need to add a return statement. And where would we like it to return once it's done the adding? Well, I would like it to go back to the home page and then re-display the new to-do list that has the added item. In order to do this, in order to send our app from here back to here, we use something called a redirect. So basically, I'm going to use the redirect function from the app, and then I'm also going to use the URL for function, which is very useful. The URL for function allows me to put in the parameter display. So now the URL for display is going to be this. As you can see, the display's URL is this. And then when I call the add function, it does the addition to the list, and then it redirects us here, which is exactly what we want. Let's test this out. Okay, let's look at it. So the new address that we created was add and then slash a wildcard. For the wildcard, I'm going to put in whatever I want. Let's say horse riding. Notice how I can even put a space in the URL. Now, you can see that when I pressed enter, it didn't stay at that URL that I typed, but instead it redirected us to the home page. And as you can see on the home page, it shows us the complete list. This is awesome. It works. It works amazing. Let's do another one. There you go. Did it again. Brought us back to the home page, and now it has the full list here. Now let's complete the app by adding an app route to the remove function as well. I'm just going to copy this from here, and then instead of the add, I'm going to say remove. And once again, there's no return here, so we need to add that. And it's going to be very similar. I just want to show the home page once again with the updated list. Let's go ahead and check this out. Okay, let's add a few things. Now let's try the new endpoint. Remove and then wildcard. And this wildcard has to match the exact element name. So there we go. Awesome. We now removed cooking from our list and we got redirected back to our homepage. Excellent. That's it, guys. We just made a to-do list app using Python. We can make this a tiny bit fancy by using some HTML. Let's go ahead and do that. I'll create an empty string. And then for every item in the to-do list, I'm just going to add some tags, HTML tags. Like this. So this should work. Let's check it out. Oops, I forgot to return the string. Awesome, look at this now. It looks awesome. Let's add. Voila, amazing. And let's remove finally. Amazing, amazing. This is awesome. So with a little more than 30 lines, we've constructed a web app that can display a to-do list, add items to it, and remove items from it. This is just the beginning. This is the very basics of Python. As you learn more, you'll be able to create even more awesome applications. You can make robots, you can make games, you can make web pages, you can do pretty much anything that you can imagine using a computer, using Python. So I hope you guys will take the time to try out everything that I've taught you on your own and try to tinker with the code so that you see what things do when you change them, and take this as an opportunity to begin learning the wider discipline of programming. And if you'd like to learn more, if you liked what we did right here, then please like, comment, and subscribe. We're always making more videos, and we love to hear from you and make more tutorials that teach you exactly the kind of things that you want to learn. Anyway, thanks a lot for hanging out and learning with me. Have a great day.